Hey everybody, this is Remy, and this video covers the Math 124 note outline for Chapter 3, Section 3, Analyzing Graphs of Quadratic Functions. Okay, so a parabola is the graph of a quadratic function. So if you graph something in the form ax squared plus bx plus c, it comes up with a shape that we call a parabola. And then there are going to be two types of quadratic functions that we'll talk about. First, f of x equals a, parentheses, x minus h, quantity squared, plus k. And then the second one is the one we've been working with a lot, which is just ax squared plus bx plus c. So they both will create parabolas, and they're both actually quadratic functions. You can take this form and turn it into this form, and vice versa. This one I know as Vertex Form, and then this one as Standard Form, but your book doesn't really have a name for either of them. And first we'll talk about some characteristics of parabolas. So this shape here is the graph of a quadratic function, so it's a parabola. And the vertex of the parabola is this point here where it reaches the highest, where it reaches a max. So the vertex of the parabola would be the point 2, 1. And then another characteristic would be its axis of symmetry. So that means where can you draw an imaginary line that would cut it into two symmetric parts? Well, that would be right here. So the equation of that line, which we already know how to come up with, that would be, it's a vertical line, so it's x equals 2. And then we would say that this parabola is opening down. And since it's opening down, it reaches a maximum point, hits it, and then comes back around. So since it's opening down, the parabola has a maximum value at that vertex. And then the maximum value itself, the highest that it reaches is what? The highest that it reaches is 1, so the max value is 1, and that happens to occur at x equals 2. So all of these have to do basically with the vertex, because the axis of symmetry has to go through the vertex, so x equals 2, and then the max value would be the y value of the vertex, and it occurs when x equals 2. So that's just some basic vocab having to do with a parabola. Okay. So first we're going to talk about if you have a function in this form, which I call vertex form, f of x equals a, parentheses, x minus h, quantity squared, plus k, then the vertex is whatever this h comma k is. Hence why it's often called vertex form, because it's if it's in this form, you can just pull that h out, pull that k out, and that would give you your vertex. And then the axis of symmetry, well, we just saw in this example that the axis of symmetry has to go through the vertex at the x value. So here, the vertex, the x value of the vertex is h, so the axis of symmetry would be the line x equals h. And then if this number a, if that is greater than 0, then that's going to make the parabola open up. And if you imagine a parabola opening up, it's going to have a minimum in that case. So kind of opposite of the example we just did. And then additionally, this is kind of just a side note that helps when you're graphing. If you if A is greater than 0, then there will also be a point, once you'd plot the vertex, and then there's also going to be a point right 1 and up A from the vertex. And then there's going to be a point left 1 and up A from the vertex. And then if A is less than 0, the parabola will open down. And since it's opening down, it's going to reach a maximum. And then again, we have something similar here. So in that case, there's going to be a point right 1 and down absolute value of A from the vertex, and then there'll also be a point left 1 and down absolute value of A from the vertex. So we're going to use this information to help us graph a parabola in the next example. So you need to have this form memorized and understand H and K and A, how they can help you graph a parabola. Okay, so here's an example. It says f of x equals 3 parentheses x minus 2 squared plus 1. So you should recognize that this is in this form. So first thing I'll do is write down what A and H and K are. So what would A be in this case? A is 3, and what about H? This minus sign in the original equation is very important. Minus the number H. So here we have minus 2, so H is 2. And then K is this plus some number at the end, so K is 1. Okay, so we have H equals 2. And then another thing we want to consider when we write these down is A positive or negative? Well, it's positive, so I'm just going to write down A is greater than 0. Alright, so then what's the vertex? The vertex is supposed to be H comma K, so we'll have 2 comma 1. And then the axis of symmetry is supposed to be the line x equals the number h. So we'll write x equals, well, h is 2. So that's our axis of symmetry. It's a line that goes through the vertex, cuts the parabola in half. And then which way does it open, up or down? Well, we've said that if A is greater than 0, it opens up. So we'll say it opens up because A is greater than 0. And thus, it's going to have a minimum. Because again, picture a parabola opening up like that, well then it has that low point. So it does not have a maximum. I'll just write none for maximum. And then for minimum, well, the minimum that it's going to reach is that vertex. But it's the y value. This 1 is the lowest it's going to go, so the minimum is 1, and that happens to occur when x equals 2. So that would be some characteristics, and then we can use those characteristics to help us plot our graph. So we'll do that down here. Alright, and here I'm going to draw in my axes, maybe here, and here, because I'm thinking about where the vertex is. We know the vertex needs to be at the point 2, 1. So here's the vertex, so I'll plot that. And then I know it's going to open up. I know that this is a minimum. And then I need to be able to plot some more points because I don't know how wide it's going to be, if it's going to look like that, or if it's going to be really narrow, which is where this part that I put in parentheses comes in. There's supposed to be a point right 1 and up A from the vertex, and left 1 and up A from the vertex. Well, here A was 3, so if I go right 1 and up 3, there's a point. If I go left 1 and up 3, there's a point there, and then that gives us a better shape of our parabola. And then you can always plot, create an X and Y chart as well, and just plot some other numbers if you want. So like if I plug in 0, for instance, I'll get 0 minus 2. Square that, you'd get 4 times 3 is 12, plus 1 is 13. So there should be a point at 0, 13, which is pretty high. It's off the graph, but this is what our graph would look like. X, Y, make sure you put in some scaling, and then that would be it for that graph. Okay, so let's go ahead and do another example. So we're on page 3, and we want to consider the function h of x equals negative 2 x plus 1 squared plus 1. So you should recognize that it is in this form still, this vertex form. So first thing, let's write what a is, and h, and k. So what's a this time? Here we have negative 2. I'm also going to write that negative 2 is less than 0. A is less than 0. And then h, this time be careful, because the formula we're supposed to have a minus some number, so if we applied that here, it would be minus a negative 1. And then k is plus 1, so 1. So our vertex is h comma k, negative 1 comma 1. The axis of symmetry is x equals this number, negative 1, h. And that's a line. It is going to open which way? Well, for that we look at a. A is less than 0, so that means it's going to open down. And when it opens down, it's going to have a maximum. And the maximum is going to be reached at the vertex, that topmost point. So the highest it's going to go in this case is this y value here, 1, when x equals negative 1. But the maximum itself is the number 1. And then so it has no minimum. And then here I'm asking a couple extra questions. What is the range? When is it increasing and when is it decreasing? And we don't even have to graph the parabola to know these things. We can just think about the information that we have. We know that it's opening down, and we know where the vertex is. We know that highest point. So if it's opening down, it's going to go on forever, both directions down, and it's going to reach the top here at the vertex. So the range, remember, which is the y values, down to up. So if you go down to up, it would be from negative infinity all the way up to that vertex. So all the way up to 1, the max that it reaches. So that would be the range. And then when is it increasing? Well, again, if it's opening down and we reach that high point at the vertex, it's going to be increasing up until that vertex, and then at that vertex it's going to start going down. So left to right, increasing is left to right. We always look left to right for increasing and decreasing. So it will increase from negative infinity all the way up to negative 1, where the vertex is. And then it will start decreasing from there, from negative 1 to infinity. And then if you're not sure about these, though, you can just graph the function and see what the range is visually, or see where it's increasing and decreasing visually. So let's go ahead and graph it. So you have to, make your own decisions about where you're going to put your axes. So here, I know that the vertex is supposed to be at -1, 1, and it's opening down. So I'm going to put my y-axis there, and I'll put my x-axis here. Okay, I'm going to go by ones. And the vertex is supposed to be at -1, 1. So here is where the vertex should be. Plot that first. And then in this case, if you go back to the chart on page 1, when it's opening down, there's going to be a point right 1, and then down the absolute value of a. So here a is -2, so the absolute value of a is 2. So from this vertex, you go right 1, it's always right 1, and then we'll go down 2. And then we'll go left 1 and down 2. And then we have where our parabola should be. Something like that. And we can see the range is now from -infinity up to 1, from the bottom to top, and it's increasing left to right from -infinity up to here, which is -1, and then it starts decreasing from -1 on. That would be our graph. Alright, so those were two examples when it's in this form, the a times x minus h quantity squared plus k. So now let's go on to page 4. Now we are going to graph quadratic functions if they are in this standard form, the ax squared plus bx plus c. So since we don't have the h and k going on anymore, we need to have a different way to plot these the vertex and the axis of symmetry and so on. So in this case, the vertex, you identify a, b, and c. The vertex will be the point something comma something. The x value is -b over 2a. And then to find the y value, well, if this is the x value, you could just plug this into the function and it will spit out the y value. So for the y value, we're just going to write f of minus b over 2a. So we'll plug that number into the function to see what the y value is. And then the axis of symmetry, well, it's the same idea as the last time. The last time the vertex was hk, and the axis of symmetry was x equals h, so this time it'll be x equals minus b over 2a, which is still a line. And then we have the same, this a still has the same properties as in the other form. So if a is greater than 0, which way will the parabola open? In that case, it opens up, and thus it will have a, just opening up, so imagine that, so it's going to have a minimum. Additionally, just like before, there's going to be a point right 1 and up a from the vertex, and there's going to be a point left 1 and up a from the vertex. And then if a is less than 0, other way around, it's going to open down, and thus we'll have a maximum. And in that case, there's going to be a point right 1 and down the absolute value of a from the vertex, and there's going to be a point left 1 and down the absolute value of a from the vertex. So now we will graph quadratics in this form, standard form, ax squared plus bx plus c. So we should already be really comfortable finding a and b and c here. A is what? Going to have 1, b is 10, and c is 23. And again, I'm going to write that a is, in this case, greater than 0. So this time it's going to take a little bit more work to find the vertex because it's not in vertex form. But we know that the vertex should be minus b over 2a, comma, plug that in to find the y. So first we need to find minus b over 2a. So that'd be minus 10 over 2 times 1, because a is 1. So minus 5. So that's going to be the x-coordinate. To find the y-coordinate, we need to plug that in to the function. So we'd get negative 5 squared plus 10 times negative 5 plus 23. So that's going to give us 25 minus 50 plus 23. Overall, that's going to come out to be negative 2. So with these two combined, we have the point negative 5 comma negative 2. That's our vertex. And then after that, the axis of symmetry falls right out because x is going to equal this value. This is negative b over 2a. So minus 5, that's a line. That's where it goes straight through the middle of the parabola. And then we said a is greater than 0, so which way does it open? Here it's going to open up, and thus it will have a minimum. So it's not going to have a maximum, none. And the minimum, we can just look at the vertex. We know that that's going to be the lowest point that it reaches. So the minimum is the y value, minus 2, and it happens to occur when x equals negative 5. And then the range, since it has a minimum value and it's opening up, the range bottom to top, where it's going to start at the very bottom is at the minimum, which is the vertex. So it's the bottom is negative 5, negative 2. So it starts at negative 2, and then it's just going to go up to infinity because the parabola is opening up. But again, you can just graph it and double check.